like that. There we go. Right, so I actually gave this presentation the other way around, wrote it to do the other way around for a bunch of IoT folks who the whole audience sat there looking gloomy and sad and were all a bit annoyed with me at the end. You guys, on the other hand, actually may find it funnier than they did. We'll see. So basically, some of you may know this, but I'm kind of transitioning out of voice. I got, honestly, a little bit bored with it. And I thought it would be fun to go and look at like this small stuff, this IoT stuff, and see what was happening over there. And I had that kind of sudden old guy moment of thinking, oh, these guys, they're just making all the same mistakes we did. Why won't they learn? And I actually, I wrote a talk about it. So it starts from the fact that, in my view, the original IoT device and my first internet-connected device was that thing. It was a Zyxel. It was a Zyxel Wi-Fi phone. It was connected to the internet. It only worked when it was connected. It had a minimal graphical user interface. It had a couple of sensors. Okay, it's a microphone and the keyboard, but it's like, it's a device. And it mimicked an existing thing, but augmented it by being connected to the internet. So I claim that that is an Internet of thing. And the same, to a lesser extent, true of the Sapura there. So these things came out 10, 12 years ago, something of that order. And in those 10 years, we made a stack of mistakes. Like in the VoIP community, we made a whole pile of mistakes, most of them quite early on. And I'm picking 10 of them in those 10 years. And the depressing thing is that they're all still relevant. Okay? Less so in the VoIP space, but definitely in the IoT space. And I gave this talk to somebody, and he said, well, but this is all covered with in this paper, and it's true. There's a Wikipedia entry called "The Fallacies of Distributed Computing," which actually only lists 8 of them, but they're all there. So go, if you want a more academic viewpoint, that's the place to look. So our first mistake was that we assumed that there was a perfect network. Because we all came from that kind of, your T1. You got your full 64 kilobits or whatever it was, or you didn't. 2 megabits, or you didn't. Your basic rate interface, you got those bits, or you didn't. There was no dropping. It either worked or it didn't. It was a quantized thing. And so all of the codecs and all of the software was designed around the fact that you weren't going to lose any packets. But then, of course, you hit a real Wi-Fi network, and that's not how it plays out. So we ended up having to, in the codecs and elsewhere, add data redundancy. We added redundant data to the codecs. We added DNS SRV records so that you could fall over to another server and actually work around that problem. Lo and behold, Nest, you'd think they'd have learned that. But when their data center goes down, no Nest thermometer in the planet works. All right? And it's depressing. So the next thing we had with the Sapura, and some of you may remember this, is configuring it was painful. I mean, you could literally I literally spent an afternoon configuring the Sapura, not the Sapura, actually the Zyxel, configuring the Zyxel, and I finally found the reason it wouldn't join my Wi-Fi is that the font that they had on the little screen, the capital W and the little w, looked identical. And it wasn't until, and you could type it as much as you own it, auto-capitalize the first word. And I just didn't see it. So, hideous on a small keyboard. And of course, what we've done in the VoIP world is we've added auto-provisioning. Have they? Have they, hell. Honeywell thermostat. You have to type in the MAC ID and the CRC off the back of the device to get it to configure up to the Honeywell cloud. I mean, and that's just step 1 of 17 or something. Amazingly depressing how little they've learned. And you have to do this on an iPad, for goodness sake. So the next mistake we made was closed identity systems. We built these closed identity systems like, simplest case would be extensions, which are essentially closed groups of users with their own username and password and closely managed. But actually, nobody really wants that. What they want is a direct dial number. They want other people to reach them externally, and they want to be able to give this thing out. And you don't want to go through, if you know your party's extension, dial 7 now. You don't want that. You actually want, and what's more, for that to work properly, you need a federated identity system, at least at a base level, so that they can call back. Like if you make a call to somebody and it goes out with your direct dial, that number has to be reachable by their PBX in a way that they can dial back. So you end up with the E164 number space as being the baseline backbone that allows you to have these PBXs to talk to each other. And that, I mean, frankly, there's an awful lot wrong with that, but without it, it wouldn't have worked. I mean, the whole game basically wouldn't have worked. Now, it would have been nice if we'd come up with something cuter like Dundee or you know, a nicer federation, but you need something. It looks like I'm picking on Google. Well, actually, I am, but you know, they bought this company called Revolve, which people were using. People had bought devices that used the Revolve service, and then Google bought Revolve and shut the service down. So it's not a huge number, but there's 10 or 12,000 bricked endpoints because Google didn't think it was worth pushing the service over to anywhere else. And they didn't publish the API or the software. So basically, those devices were completely bricked, which is inconvenient. So the other mistake we made is we had multiple proprietary protocols. Well, not all of them proprietary, but we had multiple protocols. And if you look with hindsight, all of these, some of them cute. I mean, I loved EEX. Don't get me wrong. I thought EEX was much better than SIP, but that's not what we ended up with. SIP RTP, I suppose. So, you know, Skinny H323, EEX, Megacode Jingle. I don't see any of those out there now. Like, they were pretty much all gone. So if you're building something, and this is advice to the IoT people, if you're building something you want to last, then you want to work with something that isn't a proprietary service that can just get switched off overnight, and you want to pick something that talks to a standard protocol with multiple implementations, so that if the worst comes to the worst, you can build your own gateway, you can build your own service. And here's a note for those people who are chasing the Sigfox and the LoRaWAN and some of the other arcane network, radio networks. Don't bet against something that's IP end-to-end. The VoIP community, or rather the voice community, knows very well that if you try and base yourself around something that isn't IP end-to-end, long-term you lose. Like, you know, there are pretty much no new BRI installs. Right? That stuff is an ATM. Who installed an ATM endpoint recently? Right? It's gone. If it's not IP end-to-end, forget it. We settled on SIP. I hate SIP bitterly, but it's better than nothing. But the VoIP world, we're not doing that. Facebook bought PARS. They shut, which was a messaging protocol, and they shut it down. Now, to be fair, they did the right thing. They made an implementation of it open source, and they granted rights so that people actually have now taken the PARS thing and they run their own PARS engines. But it's, you know, that was a risky moment. Facebook didn't have to do that. Give them credit for having done it right. Yeah, VoIP world, we had insecure media. We thought it's a closed LAN. We don't need to protect any of this stuff. Turns out that that's wholly unacceptable in a lot of circumstances. Notably, and these were the first places where we started seeing SRTP, for HIPAA compliance, so doctors and medical information, and likewise lawyers, started being required by law to protect this information in a reasonable way. So we started using SRTP, and we started encrypting everything. We haven't got there yet, but we're getting there. Not so true of the IoT folks. This story is glorious beyond belief. This guy, a pen tester, goes to a DEF CON conference in London, stays in a hotel, and notices that the light switch on his wall is actually an Android tablet with an Ethernet socket on it. So he unplugs the Ethernet socket, plugs it into his laptop, runs the spoofing software on it so that it passes through, watches the traffic, and sees what the traffic is, which is great and fine and wonderful, and then notices that his light switches are numbered. They all have their own IP addresses, which is great. But then he notices that, and this is just wondrous, the subnet is the room number. And then the next subnet up is the floor. So he reckoned, and he tested this, that he could turn any light in the entire hotel on and off from his laptop. He didn't play too many games, but this, and I asked him about it afterwards. He said, yeah, I said, you know, I'd actually quite like to work with the company who did that to help them fix that problem. He said, oh, that's all right, they've gone out of business. So, yeah, and then insecure auth, which is kind of related. We had this, you know, obviously in the VoIP community, and I sort of channeling near here, you know, massive fraud in the VoIP community. This guy, and this is recent, this guy, our man Bob Foreman, who's an architect, came in one Monday morning to find a $166,000 bill his PBX had run up over the weekend. So it's still happening. We haven't fixed this problem, or rather, we know how to fix it, we just haven't delivered on the fix. So, you know, we need to use strong auth. We really don't use passwords. Passwords are the wrong solution for almost all of these cases. There are better ways to tie things down than to ask people to remember passwords. And don't go on the assumption that people won't find you, and particularly not in the IoT space, because there's this wonderful search engine called Showdown, which literally goes out and finds devices that match. They've done a scan of pretty much the whole internet for pretty much all the ports, and they've pushed this into a database, and you can go searching for keywords. So you can go searching for, SSH. Now that's not too scary, but you can go searching for any of the other clients. And this is my favorite. This is unprotected HTTP, right? So this is an HTTP service that some device, and actually I have no idea what this thing, I think it's probably a grain loader, but I'm not too sure. But the key point, and you may not be able to see it from the back, is that it's unauthenticated. This thing has authentication disabled on the HTTP port. Right, so I have no idea what happens if you press any of those buttons, but it can't be good. So don't assume that things won't be found. And then the other thing, going back to the Zyxel, updating it, oh God. Like, I can't, this page is just a page of pain, right? It expects you to have set up a TFTP server in order to update the firmware, right? Nobody ever does that, right? It just doesn't happen. And so obviously these things get hacked because they don't get patches. So what you want to do is arrange for auto update, and you want it to happen often and without user intervention. Regrettably, our friends at Chrysler didn't do this. So and this story, you need to read the full story on this because it's just a tale of woe from beginning to end. Starting with the fact that they trusted the carrier to deliver what they said they'd deliver. And that's not how it played out. They thought they were getting a closed VPN, and what they actually got was a VPN of all of their cars and all of the prepaid cards of a certain character. So you could go into a shop and buy a prepaid card that was added to the VPN that this thing was on. But the lesson here is actually not that. The lesson is that they didn't have any way of remote updating. So in order to fix this bug, they had to recall 1.4 million vehicles into dealerships to have them upgraded. I don't know what the cost of that is, but it was more than $1.4 million for sure. That's a serious thing to do. And of course, the reputational damage was enormous as well. Yeah, and there's latency, right? I mean, we learned this. We learned that, I mean, EECS in particular, but also with SIP, we came up with methods for trying to redirect from this. You know, if you went through several servers out over several continents, you knew you would get audio latency and people would start grumbling. So, you know, you try and route it, and WebRTC has done this quite nicely. You try and route it as locally as possible. So if you're calling from one extension to another in the same building, you don't want to route through the server that happens to be on another continent.
Protest. SIP was designed that way, but the legal requirements and other stupid things, like NATs, forced us to bring stuff up in the cloud. But SIP is a peer-to-peer.
I didn't blame SIP for this. I'm not blaming SIP. I drew a nice diagram. All right. I'm not actually, because this was written for the IoT people. So it gives you, if you can go locally as possible, you'll get better experience. It actually protects you to some extent from server outages. And it enhances privacy as well, because you can end up with end-to-end encryption and you don't have a man in the middle, which addresses Euler's point, which is that legal intercept means that in some cases you can't do that. But for the IoT space, legal intercept doesn't yet exist. It may do, but for the moment it doesn't. So this is, you have to worry. If you've produced a product which gets that quote in the review, you have to worry about it. It says, for those of you who can't read it from the back, it says, it's amazing how much you miss a simple old light switch when you have to pull out your phone, fumble through a poorly designed app, and then wait half a second for the light to turn on. And so, bless him, he videoed this. I mean, that's livable with just, but it's still fantastically irritating. And then the final thing, and I kept this till last because it's the best, is if there aren't any user benefits, people won't use it. It sounds obvious, but it took us a little while in the VoIP community to get over how shiny it was to be able to route calls over the internet, to work out why it was that people might wish to do that. And we came up with two reasons, either because it was cheaper, which was mostly what we did in the VoIP community, but to an extent, because it increased functionality, because we could have smart conference calls, because we could, do stuff that the telcos chose not to give us. So there's a combination of those two reasons. So if you don't think about the user first, then you won't have any users, actually. And I had another example here, but Matt Jordan shot me down by mentioning it, and I thought, well, I've got to find something worse than the connected wine bottle. And I did, actually. I found the internet-connected bottle opener. It messages your friends every time you open a bottle. Why? Just why? And I have to give credit to this Twitter account, which you should all follow. It's regular reading for me. It's called The Internet of Shit, and it's basically grumbling about absurd IoT projects that people shouldn't have done. And it's glorious, and I strongly encourage you all to follow it, because it'll keep you grounded in some sort of reality. A grumpy reality, but a reality nonetheless. So, and this comes back to the VoIP thing. For me, the pinnacle of VoIP, the thing that has learned most of those lessons and tried to ingest them into the protocol is the wire protocol for WebRTC. We've tried to build all of those lessons into, to an extent, actually, they are all in there. It's secure by design, it's peer-to-peer, it's web-based, which means that you get the provisioning for free. The provisioning just happens, as does the updating, because it's in a Chrome browser, and the Chrome browser updates every month, and the provisioning happens when you load the web page. So it's kind of all automatic. It's real time, and pretty good real time, actually. It does voice, video, and data. And it's in 2 billion browser endpoints.
No facts.
And it's open source. And it's a standard. And it's... What? No, it's fine. So, and here's the thing that I wanted to bring up, more for the IoT people than for you, but I think, because most of you are probably aware of this, but it is interesting, that WebRTC can carry data too, or indeed it can carry data on its own without doing anything else, which is kind of fun. So what you have in front of you, or me rather, is, now, can we, yeah, there we go. So what we have here is a MIDI keyboard connected, which I'll show you in a minute, to Chrome in the browser here running Web MIDI. And that's playing, that has a synthesizer. And then we have, let's see if we can get these the right way up. Here we go. Otherwise we won't see them. And then we have WebRTC running in Chrome, running up a data channel. The data channel is then talking, starts a data channel session to a little WebRTC stack on the BeagleBone. And then the BeagleBone is talking to driving these LEDs through a beautiful program, open source program called Ledscape, which lets you drive RGB LEDs by sending them UDP packets, which is just wonderful. And then I have a bunch of these LEDs. Now I'm going to do something really. Since I was banned from doing a dangerous demo officially, I thought I'd do an unofficial dangerous demo. And let's see whether. Oh. Ooh. Is there anything I can do about that?
Crash and burn.
It's a crash and burn. It is. That's depressing.
Second row left.
So I have a.
Second row left. No mouse.
Yep.
This one?
Yes.
Second row left.
And then
Other
scale.
side.
What do you think?
More.
Now the projector won't be.
We are scaling.
There we
Hey,
go.
there we go. Good recovery.
Now, the question is, can we get this to do anything? Yes. Okay, so that's good. Now we need to get some LEDs to work. I'll try and put this in a different window so we can see them both at the same time.
This is one channel.
Now, the point I'm making here, and if Randy could come and play some real music, that would be better. But the point I'm making here, and actually, can we cut to this camera, please? So the interesting thing here is that when I strike this key, there's almost no latency, as compared with the light bulb we were seeing earlier. So let me give you a microphone. Yeah, go for it.
Oh. Yeah, no latency.
You're just trying to crash it now.
How many can it do at once? Let's go.
So. Thank you. I'm much appreciated, and it's better than my piano playing. So the lesson there is, if you see any IoT people, tell them two things. Tell them to go and follow the Internet of Shit on Twitter, because that's the first requirement. And then the second thing is, tell them that we learned this stuff, and it's not that hard to get it right, because we've got it mostly right in this community. Thank you.
Well, good questions. Again, speechless, some of us, but
No,
question there, or?
yeah.
One for me. Then, as you are one of the guys that spent a lot of time in voice, now trying to move out more or less, or do more interesting things. Where you think that maybe voice and IoT, or telecom and IoT, or real-time and IoT will meet at some point, or it's better to forget about all the telecom stuff? And because I hate the regulations, I'll try to avoid it, but you're more watching the space. And do you think it's going to be a lot of regulation regarding IoT and telco trying to control the infrastructure?
They'd love to, but I'm not sure it's feasible. I just think that the scale of the problem is like, you know, multi-billion endpoints pretty quickly, and a lot of them want to talk locally, and telcos aren't set up for, like, you know, you've got if you're running one of the biggest interesting cases are in things like warehouses and farms, where actually everything is talking within a few hundred meters of each other. And the idea of running that over a national telco backbone just makes no sense. So I think either they're going to have to adapt how they work quite radically, or they're just going to miss that boat.
But 1 cent per each notification will not be bad for them, right?
Right, but
Okay.
Nobody's going to pay that money.
Yeah. Okay, here we have a question.
Yes, regarding WebRTC, don't you think it's a bit heavyweight for like an 8-bit embedded system right now?
Yes, but it's not acceptable to have. So the heavyweight bit is running the crypto, basically, but it's not acceptable to have unprotected devices that are communicating over any distance at all. So there's a interesting space about devices that have a lightweight processor but a crypto engine that will do the communication. And I think that's a place where WebRTC may struggle. I'd like to look at it. But everywhere else, if you're capable of running DTLS, and all of the embedded platforms are, then you ought to be capable of running the WebRTC data channel, because it's actually the heavy bit is generating the keys and running the crypto. The rest of it is, like, SCTP is not that heavy. And all right, there's a bit of pain parsing the SDP, but really you could do that in any language. So it's doable. It hasn't been done yet. And no, if you strip the codecs out and the video and the audio out, the underlying protocol isn't that heavy. That's my contention. I mean, it's running on a BeagleBone, and that was written in Java, right? It could be optimized by a factor of 10 without any problem.
Okay. Thank you, Tim, and thank you.
And thanks for inviting me. I appreciate it. Oh.